Since the Industrial Revolution, the best places to catch a glimpse of the future have been scientific laboratories, for it is here that the novel products we will use for years to come are conceptualized and first prototyped. Technological products, especially when mass-produced, have benefited humans so greatly that today a nation's progress and future prospect depend upon the strength of its laboratories and industry. By this yardstick, India, home to nearly 1/6 of the planet's population and a modernizing economic superpower, has lagged behind the developed countries. Yet, as another technological era dawns, that of miniature machines, integrating micro and nanostructures with smart materials and electronics and promising myriad novel applications, Indian laboratories and industry have a new opportunity to advance to the front ranks of the world. This realization led the Defense Research and Development Organization to launch its futuristic and ambitious NPSM and NPMAS programs, starting in 2000 AD.
India essentially missed the silicon microelectronic revolution. However, I feel it should not miss the micro-machine revolution. Micro-machine technology is nothing but incorporating the silicon microelectronics technology to miniaturizing mechanical components like gears, machines, cantilevers, beams, etc. Can you imagine the potential application if we can mix the microelectronics and micro machines on the same chip?
As many NPMAS projects near completion and make the transition to industrial manufacturing and real-world application, India is witnessing the fruition of one of the most promising technologies in human history. In the Aerospace and Structural Health Monitoring Park, NPMAS researchers are developing 25 mass technologies offering benefits of miniaturization, performance, cost, and smart materials. For example, at the Indian Institute of Science, Bangalore, investigators have successfully prototyped a system that addresses a flying hazard, ice, on wings, causing loss of lift and producing wind drag. The ingenious solution is to use piezoceramic and electrostructive actuators mounted on the inner surface of the wing's leading edge. These produce minute but powerful vibrations to crack and shake off the ice even when the plane is in flight. Noise levels in the cockpit of India's light combat aircraft can be quite high. To counter this, a NPMAS research team at the National Aerospace Laboratories has developed an active noise control system for the pilot's helmet. Wearing this, even if the din in the cockpit is high, the pilot will hear it at much lower levels. Miniaturizing accelerometers and other sensors is an important goal in aerospace applications. In advanced NPMAS-supported laboratories, investigators at IIT Kharagpur are designing, fabricating, and testing MEMS-based indigenous accelerometers that offer advantages in size, performance, and lower costs. Development of original bulk micromachining methods application-specific integrated circuits, and other capabilities is important to NPMAS's broader initiative to make India self-reliant in these technologies. Using laser Doppler vibrometry, NPMAS investigators at the Indian Institute of Science are developing a portable system that rapidly inspects aircraft components and detects damage. The technique does not require disassembling of the aircraft and therefore offers major cost, time, and convenience benefits in real-world applications. The technology may also be used to detect damage in civil structures. The project requires development of original software and actuator excitation methods. The majority of NPMAS and Aerospace Park projects cater to India's strategic defense requirements. Yet, the micro and smart systems being developed offer major benefits to the common man and need to be commercialized into affordable products. Therefore, private industry participation in NPMAS has been crucial, particularly in the automotive and biomedical fields, which meet important social obligations in India and the world.
It was Dr. Atre who realized the importance of MEMS in industry and promoted this activity in the NPMAS program. Then we wanted to know which industry will come forward quickly to cooperate with us in developing these technologies. By that time, automotive industry was coming up very well in the country, futuristic market, competition with foreign industries. So we thought, why not we address this? We approached the SIAM and ACMA, the two agencies which are very active in automotive industry. They also came forward to interact with us, and we started identifying the market, identifying the requirements, identifying the technology development for automotive as well as manufacturing industry to start with.
An important requirement of the automotive industry is for real-time data that enables critical decision-making by the vehicle's electronic control system. Investigators at the IIT Kanpur are using Hall effect sensors to process information about pressure on brake pads, angular rotation of car wheels, and other parameters that would enable manufacture of Indian anti-lock braking systems. The team has also prototyped integrated vehicle health management subsystems to assess damage to steering systems and other faulty parts using microprobes for torque and other forces. NPMAS has brought together Semiconductor Laboratory in Chandigarh and Automotive Corporate Trecall from Coimbatore to successfully design and manufacture MAP-TMAP sensors for Indian markets. The microfabrication of the sensing element is being done in SCL's modern and PMAS-supported facilities, while packaging, characterization, and mass production are Trecall's responsibility. The devices will substitute imported components at lower cost. Biomedical, food, and environmental sciences benefit greatly from the potential to create miniaturized labs on chips with micro and smart systems. The park is close to bringing several drug delivery and diagnostic products to stores on Indian streets. Cardiac diseases are a leading cause of mortality the world over, and Indians are particularly susceptible to it. But an innovative cantilever-based microsystem developed by NPMAS researchers at the IIT Mumbai now makes it possible to detect its early onset. The team has developed a novel polymer that replaces the common silicon die for the purpose after 6 years of effort. the diagnostic device is ready for clinical trials in Indian hospitals, following which it will serve an important healthcare need. The sensitivity of micro and nanoscale devices has been exploited ingeniously at the IIT Mumbai to negate threats to public security. The creation is a portable gadget that detects trace amounts of explosives like TNT, RDX, HMX, and PETN in seconds. The team has developed a novel fluorescent polymer that is used to coat capillary tubes fitted into the appliances. Even air bearing femtograms of explosives changes fluorescence in the capillaries, enabling immediate detection. To bring the appliance to market, the IIT Mumbai team has collaborated with Big Tech Private Limited, who have developed the control electronics and packaging. The Infrastructure and Human Resources Development Park takes a pan-India perspective in commissioning facilities and projects to nurture micro and smart systems expertise. Under infrastructure, the park is building comprehensive fabrication, characterization, and packaging facilities accessible to all geographic regions of India. For example, in Rajasthan, at the Central Electronics Engineering Research Institute, advanced equipment was installed under NPSM for several processes. Now, NPMAS is augmenting its 6-inch wafer facility with RF sputtering and PE chemical vapor deposition systems. In Pune, at the Center for Materials for Electronics Technology, NPMAS is enhancing its low-temperature, co-fired ceramics facility with instruments for ceramics packaging. At Semiconductor Laboratories in Chandigarh, under NPSM, several specialized instruments were acquired. Now, under NPMAS, its micro-electromechanical systems facility is being augmented with several new instruments. To characterize fabricated devices, NPMAS has created 2 advanced national facilities that provide services to Indian projects and aim to formulate new testing standards for micro-electromechanical systems. At the Indian Institute of Science, Bangalore, NPMAS has facilitated characterization of devices, material, and mechanical features. The 2,000 square foot facility houses a wide array of sophisticated equipments for the purpose which many NPMAS projects utilize. The radio frequency MEMS characterization facility at the IIT Delhi is particularly useful for RF communication devices which have multiple uses in defense applications and the commercial sector. A successful pan-India movement to harness the potential of micro and smart systems requires strength and numbers in human resources. NPMAS has implemented a National MEMS Design Centers scheme to achieve this end. Across India, 65 colleges house NMDCs, which are accessible to students from all departments. Here, expensive industry-standard software for designing micro-electromechanical systems has been provided at no cost. Students at the center learn fundamentals and design innovative devices, some of which are then selected for actual fabrication and testing. Leading NPMAS-supported facilities also organize hands-on training for advanced students, such as the module on pressure sensor fabrication and testing at CIRI Pilani. An important offshoot of training activities is the publication of India's first university-level textbook on micro and smart systems, authored by scientists associated with NPMAS. Research and Development Park focuses on pushing performance envelopes of existing micro and smart systems applications in India and on introducing entirely new technologies, particularly for low-cost indigenous exploitation. Commercially available shape memory alloys promise multiple new applications in aerospace industry. However, these alloys operate reliably in a low temperature range. A NP-MAS team from the National Aerospace Laboratories has created a new nickel, titanium, and platinum-based shape memory alloy that extends operability range to temperatures up to 250 degrees Celsius. Informed by industry requirements, Park 1 investigators at the IIT Kharagpur have developed thin-film gas sensors that use indigenous nanostructured materials. The sensors detect trace amounts of harmful gases like nitrous oxide, carbon monoxide, and methane. The detection system will monitor air quality in car cabins. It also has major applications in India's mining fields.
In the fourth year of the program, I do believe we have achieved major part of the goal. In another couple of years, by the time we end the program, I hope we won't have missed the micro machine revolution.
As NP-MAS approaches its final phase, scientific laboratories across India realize their true significance on the country's map. And as their numbers grow, India will witness a mass movement, surpassing in value even the most momentous episodes of her illustrious history.